Okay, so today's lecture is going to be covering 3D printing. So we're going to create a 3D print ready file that we export from Rhino. So we've been working in Rhino. We have a 3D model of a house. What we want to do is have a file that we can then 3D print using Ultimaker Cura. Cura is an open source software used by multiple 3D printer companies, very reliable. It's the world's #1 3D printing software, so it's pretty common. But we're going to talk about how to make your model ready. So that includes making all of the geometry a solid, so making everything watertight and making sure that it is printable, and kind of understanding the way the machine works. The machine is going to take G-code and print the house layer by layer, print the model layer by layer. So to understand that, we should understand how the machine is going to read that G-code, what it's doing. It's essentially printing in the X, Y direction, and the 3D print head is moving in the Z direction. So the build plate is going to slowly receive the material, and you're going to just build up on layer by layer on top of the build plate. So the first thing we need to do is make sure that the model is watertight and that we have only solid surfaces, solid geometries in the model, because the 3D printer will only see, it'll only recognize and be able to print 3D geometry. So if we were to look up 3D printer G-code and just look at some images of what that looks like, it's essentially a code that the 3D printer will read, and it's going to build up layer by layer what each layer of that model is going to look like. And so the code itself is what it's reading, and the actual print is what it's going to produce. So this code, these are basically axes, and it's telling the 3D print head where to be and where to travel along that path. So it's telling it a path by code. Okay, so we use 3D print software like Ultimaker Cura to take a 3D model, generate code, and what's called slicing. So what this is going to do, and I'll show you the steps to get here, but the idea here is that each layer of this model is going to slowly be printed from the bottom up. So it's going to take the building, which you see in red, all of the walls show up as red here, and it's just going to go layer by layer, depositing not only the material that we're going to use, but if this were to print as it is now, it's going to try to print support material, which you see in blue, throughout this whole house. And you're noticing it's going back and forth with this blue support material. And the reason for that is because we have overhangs, because this roof that you see here is overhanging the rest of the model. In this orientation, the 3D printer is going to have to build all of this blue support material underneath the roof to support it. Otherwise, it'll be 3D printing in air out here. There'll be nothing that it's printing on, and it'll just collapse and be a loopy mess of spaghetti. So the 3D printer has to design the support material. So there's an algorithm that the software has that figures out, okay, there's an overhang, therefore I need to support it with breakaway material, which you see in blue here. And different 3D printers have different algorithms for generating that breakaway material. Some of them actually have 2 extruders, like the Ultimaker. Some of them have 2 extruders, and they'll be able to deposit the final print material, but they'll also be able to deposit a dissolvable, a water-soluble support material. So you can take your 3D print, put it in warm water, and actually have the support material dissolve. So that's a very useful setting to set up before you 3D print. But again, that's in this orientation. There's other ways to reduce this, and you see that it's estimating how long this is going to take to print. It's estimating 3 days, 1 hour, and 24 minutes. So that's a long print, and that has to do with the amount of support material that it's going to have to go back and forth to print. So if there's a way to print this without all that support material, that would be ideal. So part of this exercise is optimizing the print so that it doesn't have to print an entire volume of support material, right? If we take the roof off and just print that flat on the print bed, or if we, laser cut a portion of this instead of 3D printing it because it's just flat, there's a lot of clever things that we can do instead of just sending this model to be printed, because like any tool or any machine, you have to know how it's going to work and kind of what it wants to see and ways to make it more efficient. And so that's our job as designers, is to understand the tool and understand how our workflow can adapt to that tool.
Is
yeah.
Cura supposed to be in photo?
Okay, so
once you download Cura, then you can import the.
Okay, so this tutorial is going to cover how to make everything solid, how to optimize the model for 3D printing, and then how to do some basic checks. We want to make sure that there are no open seams in the model, that the whole thing is closed, and that it'll print properly. We don't want any single planes. So just to kind of show what the difference between a closed object and an open plane or an open object is. So I'm going to create 2 boxes, and this one I'm going to type explode and delete that surface. If I were to 3D print both of these geometries, the 3D software would see this as a closed object, so it'll print it with infill material inside. It'll actually print this as a solid, because this is fully closed. If I try to print this, it'll have problems because it'll recognize that these are all planes. There's no actual thickness to it. It's just an infinitely thin plane. So the 3D print software won't be able to print this. It'll struggle and it'll kind of give you errors. So what we want to do is make sure everything in our model is a closed poly surface, or a closed geometry, or BREP is another term. And then when we export it, it's going to export as a mesh. When we export it as an STL file, it's going to export it as a mesh that we can then import into Ultimaker Cura or whatever 3D printer you have. Most of them have a version of Cura that you can use. So I'm going to show how to take this model and get most of it to be solid objects like this. There's a command that I like to use called show edges. So if I select a geometry and type show edges, it'll tell you if there's any open seams in that geometry. And so I've set this to naked edges. Naked edges are any edge of a geometry that's open like this. Because I selected this, add objects, it's now analyzing this, and anything that is open is going to show up as pink. So let's say I were to add this object. I'm going to say add objects, add this, and it's going to show me that all of these edges are pink. So all of these are naked edges. meaning that these would be problem areas in the 3D print. So I could, you know, start joining these together. Let's say I join all of these, type join. Now all my naked edges are along the perimeter here. So it's noticing that this is open and this would be a potential problem in water tightness, right? Because, you know, this is no longer a solid object. So that's the thing to keep in mind. This is a great tool for making sure that your geometry is completely solid and watertight. Now you may be printing with multiple geometries. So if I had a number of boxes here, all right, let's say I'm 3D printing something like this. I say add objects, and it's going to analyze all of these and notice that there are no naked edges because these are all individual solids. Another thing you can do if you want these to be all one solid, I want to join these together, for example, I can select them, and under the Solid Tools tab, I can go to Boolean Union. What that's going to do is it's going to create basically one continuous outer shell for all three of these things instead of having individual blocks. So if I go to Boolean Union and select these three geometries, hit enter, now I have one solid geometry. And if I were to open this up, if I go to clipping plane, make this vertical, it's going to read this all as one geometry. Okay, so the Boolean tools are great for adding. You can subtract geometry that way. I could subtract this geometry from that before I made this one thing. But the solid tools here, these are all very useful when you're getting ready to 3D print. You can shell a closed poly surface. So let's go back to this model. Or actually this. What we can do when you say shell closed poly surface, it's going to give a thickness to all of these walls. So maybe this is the type of result you want and you want to 3D print it. You'd go to shell closed poly surface, click the face that you want to remove, hit enter, and it's going to shell this geometry. It's going to give it a thickness. And again, that command is shell closed poly surface, and this is what you are left with. So pretty useful command when you're 3D printing. You can set the thickness of that. Another great command is the slab command. So imagine I have a polyline here, and this could represent a wall, could represent a lot of things. I can select this and type slab, and if I tell it a distance, right now it's set to 0.5, I can click, and it's going to give a thickness to that curve. So it's not only extruding it up, it's assigning a thickness and giving it some height as well. So it's a way of turning a two-dimensional line into something three-dimensional, relatively easy for a wall or floor slab, roof. Any extruded geometry works well with the slab command. Okay, so we have this model. This model was originally modeled in Revit, then exported into Rhino. So all the layer structure is straight from Revit. If we look inside, I can turn off the roof here, and I'll turn off the solar panels. Turn that off. So we can see what's left of the interior here. Looks like we are missing some walls. So if I go to, yeah, it looks like some walls didn't get exported from my previous model. these are the doors, so all the doors are showing up. I can turn those off in the door layer. I'm going to look at that. So that's a door. So the frame and the door itself can be hidden. So what I want to do is look at this model, and for any geometry that's open or a plane like these, I want to close it. So for example, if I click on this soffit, I want to make sure that this whole thing is closed. I want to join it with the fascia. So I'm going to unfold, kind of open up the roof assembly layer, look at soffit and fascia, hold Control to select both, and then right-click, select objects, and it's going to select all of that. What I want to do is join it. So this is all now one thing, and it's on the soffit layer. So now that this is all joined, what we want to do is create a solid, so that this whole thing, instead of just being a folded panel, basically, I want this whole thing to be closed off as one single closed geometry. So I could hide everything else in the model so that only this is exposed, so that I can go in and work on all of it. Or I could select it and type isolate. Isolate will isolate whatever geometry you selected and hide everything else. And you can type unisolate whenever you're done, and it brings everything back. So that's a useful command, isolate, enter. And so what it did is it's it's joining everything together. I've hidden everything. I want to be in this soffit layer because that's the layer that this geometry is already in. And I want to go in and create a solid surface around all of these interior edges. Notice how this is open. These surfaces are just planes. They're not printable. So I have to close this thing. I want to cap all of it. So a couple ways to do that. I can create surfaces a number of ways. Surface from a network of curves. I could loft. I could do a surface from 2 edge curves. That's going to be useful here. So I'm going to click on that, and I'm going to click on my 2 edge curves, enter, and it just generates a surface connecting those 2 edges. So I'm going to go around and do that for all of the geometry. Click, click. So now that's solid. So now that's capped. So I'm just going to go around and do that for all of these. And we want to do that here as well. So capping that. So every edge should be completely enclosed. If it's not, it'll be difficult to print. No, this is simply going to surface and surface from 2, 3, or 4 edge curves. So I'm going to do the same thing, drop down, surface from edge curves, click, click, enter. Do the same thing. I want this piece that you can't really see, I want that to be closed off as well. So that needs to be closed. This already is, that's good. This is closed. This is closed. Okay, once you look around and you don't see any open surfaces, select all of this, type join, and then you can select it and type show edges, or here I'm just going to hit add edges because this is already open. And what it's going to do is identify all of my open edges. So it looks like I forgot to close off this part of the geometry. So I'm going to go to Surface Tools. Actually, it was under Solid Tools, or no, Standard. drop down, and I'm going to go to surface from 2. So I'm going to select, oops, do it over here. So now that's closed. Forgot this one, same thing, enter to repeat the command. And I want to grab this too, so I'm going to select both of those. Looks like it got confused there, that's not right on the edge. So what I could do is loft. Well, it looks like that's not connecting still. So I'm just going to draw a line and then use this surface from 2, grab that line, select this, enter. And now that I have a surface everywhere, it looks like I'm forgetting this one too. I'm going to go to surface from 2, select both of those, enter. And now this thing should be fully capped and fully watertight. So I'm going to select all of it again, type join, and show edges. Same thing as saying add objects. And you'll notice I don't see any pink anymore. So I've resolved all of the issues. And in the text command line here, it's going to show you that it says it found 78 edges total and no naked edges and no manifold edges. So this is good to go. This would be printable now because there are no naked edges, there's no openings in this, it's one solid. Yeah. Okay, so I've joined everything together. This is now watertight. I can type unisolate and it brings me back to everything else. I have this model ready to go. What I'm going to do, the next step I want to do, and I want this, because this house is modular, I want to make sure that I can print each segment independently. So if I were to just send this whole thing to the printer, it's going to print all of this as one geometry, right? But I want to be able to print each of these and have this 3D model pull apart, open up, close. So what I'm going to do is split this geometry. Right now the wall is just continuous. These walls actually, I'm going to have to clean up a little bit. Notice when I click on this standing seam, this is actually just a plane. So I can hide that or delete it. So you'll want to hide all of that geometry so that it doesn't have any issues. It looks like when I brought this into Cura that it had some issues that it was bringing up early on. So it noticed that there was some issues in the surfaces here that it was noticing. Those are showing up as red. So again, we want to avoid that. So make sure to hide all of the planes. Any just 2D surfaces, you want to hide those. So hide or delete all of those. The next thing I'm going to do is split this model so that I can print this half and this half as two separate things. So I'm going to put 3 seams, one seam here, one seam down the middle, and one seam here. Okay, so I'm going to use the plane tool to split everything. So I want to create a plane that I use to split the model. So I'm going to create a plane, and I selected vertical before I finished it. So I can click on 2 places, add a vertical height to this, and then selecting this plane, I can stretch it using the gumball tool. So stretch it horizontally, stretch it vertically. And what I want to do here, there's a couple ways I could do this. I could use the split tool. So there's different ways I can split the geometry. I can split it with a surface. I can also do a Boolean subtract. So I can take this as a surface. I can use the split command. So split, and I can use that as the cutting surface, like a knife, select this geometry, hit enter, and it's going to split it. Well, it looks like it was missing that. Let's try this again. So split, select object to split. I'm going to select that. Cutting objects, select this. And now this is its own independent geometry. So using the split command, you can create independent geometry like that. So I could create another plane here. And what I did is I just split the eave. So I could also split the walls here too. So I'm going to type ungroup because this was originally grouped. I just want to split this wall. So I'm going to select this, type split, and then select the cutting object, hit enter, and now I have two independent walls here. So that would be one way to do this. The other would be using the Boolean tools. I wouldn't recommend that because that would kind of create two separate objects. I would have to either delete one, the Boolean subtraction. So when you go to solid tools, there's Boolean split. So this is going to split two objects, but it needs two solids. So if I have a solid here, a solid here, and if I wanted to split these two, I'm going to select both. And it's going to create kind of, it'll take that intersection and make three different geometries out of it. So that's another way of splitting, but in this case it makes the most sense to split using a vertical plane. All right, so I'm going to copy this. I can create a new plane over here. So every seam of the building, I can copy this over. So I'm going to select that plane, CO for copy, move it over here, move it over here, and I can select this. I want to make sure that this geometry, this plane, intersects the entire geometry. Otherwise, it's not going to split the whole thing. So I want this to extend all the way out. It can overshoot, that's fine. But what I'm going to do is select this geometry, type split, select the cutting object. So this is what it's going to use to cut. I click on that, hit enter, and I've now split this geometry into components. So here I still want to split this, so still some work to do on this. But you'll notice after I split it, let's say I isolate this, isolate. You'll notice that this is open. It's not a closed geometry. So I'm going to have to select this, type cap, and it's now a closed geometry. So when I hit unisolate, I bring it back, and now this is closed. So what I'm going to do is do that for all of the walls, do that for the floor. Actually, the floor I've modeled that way, so you won't have to do that. But you're going to take this geometry, type split, select the cutting object, and now this is two objects. So the cap command is a really useful one. Again, isolate. And whenever you have a single open surface like this that's planar and pretty easy for Rhino to calculate, if you select that geometry and type cap, C-A-P, enter, it's going to try to find a solution to close that object. Okay, so unisolate to bring everything back. All right, so I'm going to do that for all of the geometry so that everything is closed. So do that for all the walls, split them, cap them, make sure everything is closed. So I can do that for this wall as well. So ungroup first because it looked like these were selected. Select this wall, type split. And now this wall is actually 2. So I can select all of this. Well, actually first I want to make sure that this is a solid. So isolate, orbit, you'll notice that this is open. So I'm going to select it and type cap, unisolate, takes me back. I'm going to select these, I guess those are ungrouped. So I should be able to select all of this. Ignoring that, I'm just deselecting all that stuff. And if I hold Alt and drag, I can now take this portion of the model and this should be ready to print. So what I could do is take this model. If I print this, it's not going to have to print support material inside the house because there is no roof for it to support. If I had a roof enclosing all of this, this would be infilled with support material to print. But because I've done it this way, if I print this, it'll just have these walls open. So what I could do is then later 3D print the roof afterwards and then have that kind of come in to cap all of this. I could also make this soffit or this overhang part of the roof itself. So I think that makes a little more sense. I think what we would do is just 3D print the floor and the walls and then come in with the roof afterwards and kind of drop that on to create a cap for everything. So I'm gonna temporarily move that back. I'm gonna select all of this again, deselect that because we don't want it, deselect that. And I'm going to group this. So with just that portion of the model selected, I'm going to type group. And now when I select it, it's going to grab all of that at once. So what we want to do is have individual groups for each portion of the model. And we're going to 3D print each group independently. So the first thing that we need to do in order to get this to the 3D print software, we have this as a model. I want to scale this down because right now this is at life scale. This is 1:1. So if I type distance and measure this, this is going to be 16 feet. So obviously when I 3D print this, I want this printed down to scale. So I'm going to hold Alt and using the gumball, I'm just going to drag this over. I'm going to put this at the origin so that I can keep track of where it is. So I'm going to type move, select the corner or select the geometry, enter. Click on the corner, move this to 0. And I move it to 0 by just typing 0, enter. All right, so I can select this. I want to scale it down. So to scale it down to an 1/8 inch, what I want to do is create a scale factor that makes sense to scale this. If I know that's 16 feet, at 1/8 inch scale, that's going to be 2 inches, right? So from here to here should be 2 inches at 1/8 inch scale. So I'm going to select this, type scale. I want to make sure it says scale, not scale 1D. Select that edge, this edge, and before I click a third time, I'm just going to type 2 inches, enter, because I know at 1/8 inch scale, that module is going to be 2 inches. Okay, and then with that still selected, I'm going to go to standard, click on this zoom selected, and now it's the right size, so only 2 inches. It's a small model. And I'm going to select this and type export. Okay, I'm going to export it as an STL file. So from the drop down, it's a stereolithography file, STL. We'll call this module 1, print, and hit save. And then here it's gonna ask you which units you want to print in. It's gonna also give you the kind of tolerance for that model. It's gonna create a mesh, but it's trying to figure out what kind of tolerance should it use when it triangulates that mesh. So I can go to detailed controls, change the density if I want. I'm just gonna leave this as is. Let's try that again. Type export it as module 1. Save. I'm going to say OK. And just leave that as is. Export open objects. You can uncheck that and it's only going to export the closed objects, so solids. And then I'm going to open up another Rhino dialog here just to see what that file looks like, because you're going to see it as a mesh geometry, because that's what STL files read. So I'm going to type import, and I can import that file. So it's going to ask you what units it was in, inches. Looks like it was modeled in feet, so we'll have to double check the size of all this. But going back to this zoom selected, I want to take a measurement. So this is the mesh file. I'm going to turn on shaded view because we're in wireframe. And this is the triangulated view of that model. So you're seeing this triangulated mesh. Each of these is its own thing. I can select this and type show edges, and it'll identify any location where I have an open edge, and it looks like there's a few here, partially because these windows were actually just planes. So that's a problem. We'll have to delete those. When those exported from Revit, it exported each surface of the window independently. So that's going to have to be corrected. It also picked up this opening here. If we go to Mesh Tools, and there's a way that we can close any open holes that we see in a mesh, similar to the cap command. Let's see. Fill mesh hole. So I'm going to select that, click this edge, and it's going to do its best to calculate a closure for that. And it actually did. It did a decent job of that. So now when I select that and type show edges, this is now closed. So this is the command I used, fill mesh hole. So that did a decent job. And that's when you're dealing with a mesh, right? If that were a poly surface, I could just type cap and it would close it. But since we're in mesh world now, it's a different set of tools. It's a different kind of type of working. We also want to check the size of this. So I'm going to type distance. We'll do a quick measurement. 0.01 feet. So yeah, we know that that's off. So what we should have done when we imported it is set the import units to feet, because that's what this was modeled in. So instead it's a lot smaller than it should be. But so we could re-import it and do all that again, but we've already done some work on this. So again, at 1/8 inch scale, I know that that should be 2 inches. So I'm going to still select this, type scale, make sure to fully type scale, select this, select that, and type 2 inches, enter. And so now I have a geometry that should be ready to print. It is still reading each of these as planes. These were kind of our sheet metal on the exterior. I can delete those. Delete that, because we don't want the individual planes. We want these as all closed objects. For these windows, we can delete these. If we want this to be open, we can do that, and it'll just put support material in there. If I want to create a mesh that's kind of a mesh box in here, I could do that as well. But I'm just going to leave these open for the sake of this demonstration. But if you wanted to put something in there, just make a solid object. Okay, so those are ready to go. Once this is ready to print, let's try this one more time. Select it, type show edges, and it looks like there's a few other surfaces in here that should get deleted. And most 3D print software is going to find a way to solve a lot of these issues, but we just want to be as clean as possible in this model so that there's no surprises when we go to print. So some of these might be resolved when it goes to the printer, but we just want to be extra careful. So I'm deleting all of these added surfaces. I think at some point these were panes of glass that got exploded into multiple planes. All right, so now if I select this, show edges, it says no naked edges, so we're ready to print. And since this is kind of down to its bare bones, it really won't require much support material. If I print it in this orientation, it won't require supports. Maybe, you know, yeah, actually it'll put some support material in this window that I can then break away later on. Imagine if this model were oriented this way, right? It still wouldn't require supports. If it were oriented this way, it would require supports, right? It would have to support this entire wall. So the orientation that we print matters. So just being smart about reducing material, reducing the amount of support material that it's going to need, that can save you a ton of time and material waste. When you consider this is often ABS or PLA plastic, just reduce the amount of plastic waste that's out there. So I can select this. Actually, I could just save this because this is a STL file. I could save it as an STL. Call this V2, save, okay. And then, yes. Okay, so we have this model, we've saved it as an STL file. I'm going to create a new file here, new project, yes. And I'm going to open up that STL file. This is V2. And you'll notice that it's reading this in millimeters. So one thing that we may want to do is make sure that either we change the units in the 3D print software, which I don't know if we can do easily, or we just export it in millimeters. And I think that's what we're going to have to do here. So it is the right size. Now we just have to export this. And first, let's just change the units. So I'm going to type units. We're going to save this in millimeters. Hit OK. And it's going to ask you, do you want to, when you change the units, should it change the model size as well? And if you say no, it's actually going to, the model is now going to be the wrong size. So you actually would just want to say yes, so that it brings this to be the actual size. So when I type distance and I set the model units to inches, it's going to tell me that this is still 2 inches. So whenever you do a units change, always say yes when it asks you, do you want it to scale the model? Because what it's going to do is it's actually going to keep the model the same size. It's not going to scale the model. So if you want to keep it the same size, always answer yes. So with that, I've now made this Rhino file in millimeters, and I've made it the right size. I can then save this as an STL. Call this V3. And since this one is in millimeters, when I import it into Cura, make a new project. If I open V3, it's going to come in at the correct size. And you can see how small that is. It's going to be a small print. But the thing that we want to make sure is that the wall thickness is still within the minimum thicknesses for this print, right? We want it to be within tolerance. You can only print a certain width. For every printer has different requirements for how thin the walls need to be. So you can't go, you can't make it paper thin. But at 1/8 inch, this is about 6 or 8 inches for that overall wall thickness. So that means we're a little over a 1/16 of an inch for the walls at 1/8 inch scale. So we're good. We know that the thickness is okay. And when you have small details like the standing seam metal on the wall here, we know that's going to work out because that's part of the surface itself. If this were a standalone column, that would be a lot harder for it to print. But the fact that it's attached to a solid wall, this should be a lot more doable. Okay, so with this, we want to go to the settings at the top. There's different settings you can give it. You can tell it to print at a fine resolution where the layer height is going to be 0.1 millimeters. If you want to go extra fine, it's going to have 0.06 millimeters, or normal, which is 0.15. So it just depends on how smooth you want these surfaces to be, so that you don't want to see every layer. So we're going to leave this at fine. That's kind of in the middle. And you can set different profiles here, so you can have different settings that you always use. And then infill. So infill, this is how much infill you're going to get inside every solid object, right? So this isn't support material, this is infill. So infill, right, like imagine the inside of this wall. It's a solid, so the 3D print software is going to try to fill it up. Now, it'd be a waste to just fill it with solid plastic. We don't have to fill it 100%. We could, right? If I bump this all the way up to 100%, it's infilling that fully. If I bring this down, you're noticing the preview here. It's going to change how it infills, right? So I can affect what percentage of infill I want this wall to have, and it's going to create a grid that's either 10%, 20, 50, 60% infill, so that there are air gaps in here, and it's not just going to be solid. Because if it's solid, it's a waste of material and time. Okay, so I'm going to leave this at 20. I can check support, and when I check support, that means it's gonna 3D print support material. If I look at the underside of this, you'll notice there's red portions of this model. Those red portions are areas that are requiring support material. So just be aware, whenever you see something red, just know that the software knows you can't just bridge that surface with a solid, window frame. It's going to have to infill that with support material. So just be aware that, and that's okay, it's just going to fill it with support. So I'm going to check this, that turns on. What you can do is you can tell support materials to print out of extruder number 2. And what you can do is you can load the water-soluble filament into extruder number 2. So you have extruder 1 printing the solid material that you want, extruder 2 printing the support material that's going to dissolve, and when you're done with your print, you just stick it in hot water and let it sit for a few hours, and it'll resolve that, and it'll remove the dissolvable support material. And again, you need the right printer for that. The Ultimakers that we have that capability, but you have to make sure that the right spool of print material is installed on that printer. So there's a lot of setup involved with that. The other solution is just to keep it with the same extruder, and then just it'll break away, and you can break it away by hand after it's done printing. Okay, adhesion. So there's been a number of issues in the past with the actual model not adhering to the build plate. So there's a lot of solutions to that. And if it doesn't adhere to the build plate, it's just gonna, move around and print spaghetti everywhere. So we want to make sure the model is fully adhered to the build plate. There's a couple ways we can do that. You can have it print a raft, which is basically like a floor under your model, and it's going to calculate what the extents of that raft need to be, and it'll give you a little bit of a surface that you can peel away from the actual print bed, and it'll help you remove your model from the print bed, and it'll help adhere to that print bed. So there's different ways you can do it. There's a brim, which is more of a thin profile around the edge, and a actual raft, which is kind of a floor. It has thickness to it. And you can set this to custom. If you wanted to update this even further, you can set the print speed. We don't really need to touch that. Infill percentage is still set to 20. And then supports, there's, we can tell it at what angle should we require support material, because maybe, with a certain material type, you don't have to, or a certain printer type or layer height, maybe you can play with, when support material gets activated. Maybe I don't have to, support under there. I do, but just with other models, you want to maybe play with that. All right, so this is spool 1, spool 2, and then once we're ready to go, this is ready to what we call slice. I'm going to hit slice, and it's going to basically take horizontal sections. It's going to slice through this whole model, and now we have something a lot more reasonable. This is 3 hours and 1 minute to print this, and it's also very small, so it's not too bad. If I click on preview, it's going to give me a preview of what it's about to print. So what it's doing is it's printing the walls that you see here in red. Auto scale walls. So it actually scaled this model. Interesting. We'll have to double check the size of this in a second. But you're noticing that it's printing build plate adhesion. It sets a brim, so it's printing this little brim around the perimeter. If we set this to raft, I have to reslice it. And now you're going to see that it's going to move the whole thing up and print all of it on its own raft here. So that's a little bit more heavy duty, a little more solid, so that when it breaks off, it'll come off as one. And you're noticing in blue here, this is all the support material in order to support these, the window frame itself. And then you're seeing every layer that it's going to use to print the interior, which is in green, and the exterior, which is in red. And I can go in and slice this to show what every step of the way is going to look like. So the print head is going to go back and forth. It's going to print each layer like this. So starting at layer 1, it's going to print the raft, print my floor that I modeled, and then start printing these walls and work its way up like that. All right, so it's going to print all of this. And so once we hit save to disk, I'll save this as my module 1 print to the desktop. Hit save, and it'll save this. So once I save that, I can put it on a flash drive and walk it over to the Ultimaker and plug it into the computer and print it.